Welcome to Scaling with Demi. This episode is brought to you by Pleda, a platform that allows you to create virtual schools in minutes.
I've missed you guys. Welcome to another episode of Scaling with Demi. It's your boy Demilade once again. For those that are on for the uninitiated, what we do here is we talk about tech stuff, interesting tech stuff, scaling a startup, building, coding, refactoring, design, and just kind of like giving perspective to some of the problems I had when I was starting my first startup as a student and some of the learning points. I mean, over the years, I've gotten some experience. I'm still trying to figure out a lot of things in my life, but I've gotten some experience in software, in coding, and in startup, and I've learned one or two things. And these are just things I'll be giving my perspective on. Let me know your perspective in the comments below. You can tag me on Twitter, give me a letter, or just send me a personal message. Cool. So welcome to another episode of Scaling with Demi. In this episode, I'm going to be talking about speed versus scale, right? And this is going to be very important for people that are just starting up. If you are working in, say, very established companies, this might not be so relevant to you because the consequence of building one or two things, right, means a million users get affected or something bad happens. But when you're just starting off with your project, you don't have the luxury of users. You probably have 10 users, 15 users, 100 users. You want to launch new features to spoken to customers, but you're now thinking as a developer, right? Do I prioritize, or as a product manager, do I prioritize the speed of development, speed of launching the feature, or do I prioritize performance, like my feature, my product being able to scale properly, like to hundreds or thousands of users, like at the end of this, right? Now, note this is not very applicable to some kind of startups. If you are biotech or if you are in the healthcare space or some military space, right? You don't want to do Aki project, right? The consequences are quite significant. Someone could get hurt. But if you're like a social media platform and an education platform, a SaaS, I mean, you can get away with one or two errors or mistake. And since you're very early, I'm going to assume you've not gotten like product market fit perfectly. So you're still trying to figure out what sticks, what products your users are using. Now you're definitely talking to customers, right? But you still don't know. And customers will tell you, oh, build A, you build A, you don't end up using it. So you're still trying to figure out all this shit. So which should I prioritize? Speed of development. Can I get this feature out in a day or two? Or the performance of the feature, getting it to scale to relatively infinitely. After I dwell on the speed of versus scale, I'm going to, for those that choose to go to scale eventually, or when you get to the point of scaling, you would need to understand some concept like autoscaling, how to set up autoscaling. So I would give a very shallow overview on autoscaling for product managers, for developers, or people that are interested, tech enthusiasts, just so you have an idea. So when the developer is just telling you, oh yeah, you can say, bro, I've listened to Scaling with Demi. I know what you're talking about. I'm not dumb. So yeah, welcome once again to Scaling with Demi. Speed versus scale. For me, with exception to the companies I mentioned earlier, military, health, and maybe a few other companies, I would pick speed of development. And you ask, why do I pick speed of development? One thing you would learn really quickly is it's very difficult to preempt what users would want. I mean, hardware too, right? For hardware, you don't want to do speed of development because it's quite costly to do that. You want to be very sure. But for software, right, you want to be able to churn out features as fast as possible. And since you can't preempt easily what users would want, right? I mean, even though users are telling you, oh, this is what I want, or your insight editor is leading you to build this, you want to put these features in the hands of users and see how they use it. Now, it's better you put a feature that is half-baked in the hands of users that works, it solves their problem. Maybe a few wonky flow here or a button that is misaligned a little bit or a color that is not very ideal. I mean, there can be some inefficiencies, but it's better to put this feature in the hands of users, get their feedback, get them to complain that this is not working. Or they don't have to complain, but see them use it and see them go through the pain of trying to use it. And you know that, oh, this is something worth spending more time on than you trying to optimize and make everything perfect. Then you now give it to users. And it's very important. I'll talk from experience, right? At Playda, we built an online video editor, right? Playda is a platform that allows you to create a virtual school. So we built an in-app creator suite for you to record videos, record classes, without you having to use cameras and fancy gears like I'm using right now, microphone, just a laptop, record, edit, and publish. But we're not sure if people are going to use this feature, right? So we We deployed it to a server, not much cost. I mean, we're a startup, so we did not want to get too much cost. We deployed it there. The library FFmpeg we were using could not scale perfectly. We later realized that. But then still, we deployed the interface to the users. And some people used it to record short courses, 5 minute, 10 minute courses, 15 minute courses. But then it got to a point whereby some people started using it to record 1 hour courses, and our server started reaching its limits in terms of scaling. I'll talk about auto scaling more down the line. But our server started reaching its limit. Now we had installed auto scaling groups, so when a server reaches its limits, new servers are automatically spun up to accommodate the request that is coming from the front end. So our server never goes down. Even if the server goes down, there are other servers that can accommodate it. However, the people that recorded their video were still having bad experience because that single instance on its own reached the CPU and the memory limits. Other users were not affected by this problem, but then the video could not be processed. And if you've ever worked with media processing, you know that it's a pain in the ass, right? It can get very difficult to do. And some people were like, oh yeah, people needed this feature. So people were saying, oh, my 30-minute video, my 1 hour video was not processed adequately. Can you guys help me look into it? And we knew that, yeah, this is a feature people really wanted. We spent some time. We redesigned the architecture. We started streaming the video that was created to the back end instead of playing it at once. And we made it better eventually, right? But we have many other features that we've built that users, we could have spent X number of time building it in total. Instead, we ended up spending 1/4 of that time. Users did not even bother engaging with it in the first place. We tried to tell people, but they did not use it. And we knew that it was better we did not end up wasting. Thank God we don't waste so much time on it, right? So let's just scrap it. Now, this is my opinion. You might have a different opinion. I want to know what you think. But I would almost always pick speed of development, especially in the early days. Now, when we did the experiment, we were a relatively small startup. We are still a small startup, by the way, but when we did this experiment, we were still relatively small. So it was the impact of some inefficiencies in new features was not going to be that significant. Only people, and not everyone had access to that feature. We kind of like scoped it to just a few users. We told them about it, that it's a feature we're testing now, just try it out. And you're like, oh yeah, this does not work. But it did not affect the existing flow. One thing to note though is that, like, no matter what you do, don't try not to break existing user flows, what they are used to, what they understand. Try not to break that. So I go for speed. Let me know if you have a perspective that goes for scale, right? And by speed, once again, I'm talking about speed of development, not speed of sites. So to dwell further on scale, what are the things that could potentially affect your speed of site when you are building a website and an application? What are the things? Before I even go into that, right? If you have an application that users have to download, it might be a lot harder to update when there's an error. So you might want to be more conscious of changes you made, right? Or find a way to force them to update an app or download updates internally without it affecting the user flow. Because if you have a website, I mean, it's a lot easier. All you need just to reload the site. When they come to the site, you'll see the new updates and it works. If you have an app, you might need to think more carefully around this, right? If you have an API that other people are integrating with, try to never break anything because other people's system are dependent on it. So just try not to break anything. Try not to change anything. But now talking about scale, what are the reasons why some sites are really slow? Why do I go to tomedu.com and it's taking me 10 years to load? Right, so it's taking 10 years to load. For rookie devs, right, when you are getting started or rookie products, you just patch everything together, put front end, back end, database, everything in one server. I remember I made this mistake once. I just jammed all my front end, back end, database, everything into one EC2 instance on AWS. You just started going to the site, and that simple instance was managing everything. I did not separate everything because of the site was slow actually. I separated everything because I lost all the data, all the user data. Fortunately for me, I had a backup. Another conversation for another day. But some of the things that make sites slow could be inefficiencies in one. It's a single bottleneck. So if you have a chain and one of the chain is weak, it doesn't matter how long or how strong the other part of the chain is, that chain is going to break. The inverse is true for most tech stack, right? If you have a solid, very fast system, right, very resilient stack, and you have a point that is slow or that is inefficient or that doesn't work, you can be guaranteed that that slow site is going to hold up the whole flow because usually the speed of a site is the addition of the speed of each of these components. Let me give an example. I go to a front end, right? The front end makes a request to the back end to build the user data, right? but the front end has to be loaded first, or I have to hit the front end server. After hitting the front, so the speed of, let's say the front end server takes 2 milliseconds to load, right? I hit the front end server. Front end server makes a request to the backend to fetch my profile, my user information. Let's say that request takes another 2 milliseconds, so that's 4 milliseconds. The server makes a request after authentication, and let's say authentication and whatever takes another like 2 milliseconds, that's 6 milliseconds. Makes a request to the database, right? Let's say that request to database takes another 4 milliseconds or 3 milliseconds. Everything ends up adding up. So if you have one of those places that takes too long, you can be guaranteed that it doesn't matter, right? The whole thing is going to be messed up. Your site is going to be very slow. And the reason why I mentioned not hosting everything on one single instance is that hosting them separately has some benefit. It allows you to scale the parts that need scaling without affecting the other parts, right? It allows you to scale your service independently. Usually, front-end might not need too much scaling because once the user loads the data, the browser starts making requests to the backend on your behalf. You're not doing so much processing on your front-end yourself, depending on if you're using modern stacks, right? If you're using React, once you load the React side makes a request to the backend, and just the server that is serving up the React website is not really doing much work, right? So you might not need too much scaling on the front end as much as you might need on the back end, depending on how your product is, by the way. So you can just manage that proportionately, right? Proportionally. Is it proportionately or proportionally? So in proportion to the request that is being made. When you get to the back end, you are thinking of, authentication should not be a bottleneck. So we have to isolate the backend to a different server, to a different instance, right? Set up its own autoscaling group. Then we are thinking of, authentication should not be a bottleneck. How fast is the authentication? And how many requests is it making to the database? And how long is that request taking? Note, you must have separated the database from the backend. Do not make the mistake of putting the database on the same instance as the backend. Always keep them separate. If not, restarting your server could mean potentially you losing all your user data. And if you lose your user data, you're fucked. Look, you're not fucked if you're still early, and you can still find a way around the dot. It's not good. So you want to separate the backend and the database, and so the backend has to make a request, another API request to the backend, right, to the database rather. It has to call the database, and all these requests are going through fiber optics undersea that Google and big boys provide, right? So it has to go through that again, which adds another milliseconds to the request time. When it gets to database, depending on how complex your query is, your database has its own CPU, RAM, and whatever. So it has to process the query you're passing in, right? So that one takes another time again to process, and it returns it back. So the response goes through the fiber optics undersea cable again, back to your backend, which now goes through the fiber optics cable again to your browser, right? And you now see your profile, right? So one of these flows could really mean the system is fucked, right? So one thing you want to do is now take note of auto-scaling, implement auto-scaling at each of these points because they scale differently. So in the front end, you say, okay, once my CPU, the CPU of my front end, which is 70%, I want to speed up 2 more servers, right? Ideally, you should not even have only one in case something happens to that one. There should be another one. But let's just say you want to scale. So I have 2 right now. Once the average CPU reaches 70%, I want it to set up another server automatically. There are many tools you can use to set up this. For the devs, can talk about that. AWS, ECS, Kubernetes, Fargate. There's so many tools you can use, right? So you automatically set up a new server once you reach that stage, or once my memory usage reaches, automatically spin up a new server, right? So you do that, the front end can scale. The back end, usually for my product, the back end usually ends up scaling a lot more than the front end, right? So you start to maybe like 5. Once you reach a particular limit, start adding new servers to it to grow so that you can keep handling more requests. And then for the database, you want to maybe increase the CPU, increase the RAM. You want to shard it. I'm not going to talk about sharding here. You want to add indexing. Indexing is for another episode. You want to do caching layer on the back end so you don't have to call the database. Another episode solves that. There's so much stuff to look into optimizing. But generally, right, the autoscaling term is divided into 2, right? There's the horizontal scaling and the vertical scaling. For the vertical scaling, you are thinking of, let me increase my server, CPU, RAM, network layer, bandwidth. Let me got this shenanigans, right? Let me increase all these jargons. Let me upgrade from, I don't know, MacBook 2020 to MacBook 2022, basically. But on the server front, so let me upgrade from, you get the point there. For horizontal scaling, it's let me add new server instances to my system, right? So if I have one server, for those who don't know server is like just it's basically a computer that you can communicate with. That's it. It's on the other end of the world or the other end of wherever it is, right? And you can communicate with it. So let me add new instances. Let me add new servers. I have one laptop. Let me add two, three more new laptops. For the vertical, I said you are increasing the RAM, increasing the storage, increasing the CPU usage, the CPU. For horizontal, you are adding new computers, right? There are pros and cons of this. I won't dwell into it, but just on the surface, it's a lot easier to do. Different people might have different opinion, but generally it's a lot easier to do vertical scaling because you're not really changing the computer. It's still that same computer. You're just adding new RAM to it, which means you can handle a lot more requests. For horizontal scaling, you have to find a way to put a layer before the computer because the browser does not know the computer it is talking to. The browser is just talking to your backend, but your backend is not routing that request to multiple computers. That's where load balancers come in place. I'll talk about load balancers in another episode. But yeah, but if you have a dev, just subscribe to this channel. I'll talk about many of these other points in another episode. But generally, I just know that you want to implement autoscaling, and with the autoscaling, make sure it is capped at a particular cost, so you don't wake up with $1 million bill from AWS that you are owing for because your server went up overnight and you got a lot of bills, right? So make sure to summarize. Speed is more important than scaling. If you must scale, you implement autoscaling. Even if you're using speed, implement autoscaling if you can. Set up monitoring and make sure your front end, back end, and database are isolated from one another so that you can scale them independently. And a problem in one does not cascade down to a problem with others. In the next episode, I'm going to be talking about load balancing. I'll talk about I will do more about scaling, more in depth about target group, about how does load balancing work. I mean, especially when you're thinking of it in the context of horizontal scaling, right? In which you have multiple servers, you have multiple backends. Your backend application, your backend code is running on like 100 different places, right? How does the front end know which one to communicate with? Spoiler alert, usually uses IP address or some cookies, some application header files. I mean, we'll talk about that in the next episode. But for this one, thank you very much for coming to this episode. See you in the next one. Bye.